Here's a quick quiz. What do you think? First of all, do you agree that all three numbers that I've given you, these are rational numbers? Do you agree to that?
Yes, sir.
Yes, because they are written in the form of a by b, so they are rational numbers. Some of these rational numbers will terminate, while the others will not terminate. For example, 1 upon 3, or let's say 10 upon 3. This number will go like this, 3.3333, and it will keep on going like that. We have to identify which one terminates, which one doesn't, without actually dividing. Can you do that? Okay, okay. No, no worries. Okay, that's why we are here. See, so I'll give you a rule. You must have seen that in your textbook. So let's look at the rule. If the denominator of any rational number, if it can be expressed in this form, then you can confidently say that it's a terminating decimal. Okay, you recall this rule? I'll tell you why this happens. See, 2 to the power m and 5 to the power n. If the denominator is of this form, let's say 2 cube and 5 to the power 4. If the denominator is of this form, and I'll have any integer, right? This is a rational number.
Yes, sir.
2 cube, and I'll take 5 cube from here. 2 cube into 5 cube. What is that going to be?
125 into 8.
Okay, do it like this. 2 cube into 5 cube. So 2 into 2 into 2 into 5 into 5 into 5, isn't it?
Yes, sir.
2 into 5 is 10. This 2 into this 5 is 10. This 2 into this 5 is 10. How many tens? 3 tens. So you get a 1000 here. Do you understand how I wrote that 1000 here?
Yes, sir.
Okay, now 1 5 is left because there were 4, like 5 to the power 4 was there. Let's look at this. The integer on the top stays like that. We're basically trying to find out how can I confidently say that this decimal terminates. This expression terminates. So we have the same integer on the top. Right. Okay, let me do this. What we'll do is we'll multiply something in the denominator and multiply by the same thing in the numerator also. An integer multiplied by 2, will I get another integer?
Yes, sir.
Yes. So let me write another integer. And what do I get in the denominator? Thousand into 5 into 2 is 10,000. Do you agree?
Yes, sir.
Okay. Now, any integer divided by powers of 10, isn't it always going to terminate?
Yes, sir.
Thing. That's why we came up with this rule that if we can somehow express the denominator in the form of 2 to the power n, 5 to the power n, we can confidently say that it must terminate. Is it clear?
Yes, sir. Yes, sir.
Okay, now let's go back to the question and you tell me what is the
Okay.
answer. The first one, is it terminating or non-terminating?
2 to the power of n.
Just focus on the denominator, right? So this can be represented as 5 into 10, or if you want you can represent it as 5 into 2 into 5, or
Okay, so it would be 5 square into 2.
yes, so 2 to the power 1 into 5 to the power 2. Do we have it in this form?
Yes, sir.
Yes. So will it
It's
terminate?
terminated.
Yes, this will terminate. Okay, let's look at the second one. 7 upon 8. What do you think?
No, it's not terminating.
But wait. 2 to the power 3, 5 to the power 0.
Okay.
Okay, so this will also terminate. Similarly, if I had, let's say, 3 upon 5, will that terminate?
3 upon me, I feel.
Yes, it will terminate. Okay, look at the third one. Tell me, will it terminate?
Will do this.
I'll help you factorize 72 if you want. So,
Um,
72, 12 into 6 is 72. Let's use the factor tree. This will be 3 into 2. This will be 2 into 2 into 3. Right? So 72 will turn out to be 2 cube into 3 square. You tell me whether this will terminate or not.
no,
No, it will not terminate because it's not of the
it
form
doesn't
2.
happen.
Yes. Yes. Rest assured, if this chapter is there, you will be able, you will get some questions where they want you to identify whether this rational number will terminate in its decimal expansion or not. So yeah, any doubts you have in this part, how to identify whether something will terminate or not?
No.